Okay, number 30 is a classic quadratics application problem. It says the height of a batted ball is modeled by the function h equals negative 0.01 x squared plus 1.22 x plus 3. I should have used an h, but I used to use a y. It says where x is the horizontal distance in feet from the point of impact, and y is the height of the ball at certain feet. So this is a function, right? You give me an x and I will give you a y. So you give me a distance from the point of impact, and I will tell you how high this thing will go. Now, obviously this is a quadratic, and I know that's going to be facing down because my a term is negative. So for question A, it says, what is the maximum height that the ball will reach? So again, you guys, all we're doing is we're looking for the vertex. So I'm going to take negative b divided by 2a, and I'm going to get negative 1.22 divided by 2 times negative 0.01. When you plug this into the calculator, you should get 11. So let's go ahead and verify that that's what you do indeed get. So I'm going to show you this. So over here, you would do negative, turn the calculator on. So clear this. Negative 1.22 divided by the quantity of 2 times negative 0.01. That, close that, hit the enter button, and I'm getting 61. Did I not write the problem down correctly? Timeout. Hey, sorry team, I was looking at my solutions from a different problem. I'm not 11, you get 61. Good thing we checked. Okay, so that is the distance from the point of impact that we want. Now we need to figure out the height, and the way that we get the height is we simply plug it back in. So we'd have negative 0.01 times 61 squared plus 1.22 times the number 61, and then plus the number 3. So we'll go ahead and do that together really quickly just to make sure that we don't have any mistakes here. So we would go negative 0.01 parentheses 61 quantity squared, and then plus a 1.22 parentheses 61 quantity, and then plus the number 3. Push enter. I'm getting 40.21. So this is going to be about 40.21 feet high, 40.21. And I can verify that for you too also on Desmos. So when I graph the function, remember x is the horizontal distance, y is the feet, so 40.21. Okay, so then part B is asking us, okay, at what distance from the batter will the ball hit the ground? So basically we want this distance over here. So if this is about halfway, which is like 40.21 feet, if we just double that again, another 40.21 feet, it'd be about, so part B would be about 80.42 feet, or about 81 feet. And check this out. If you go to here and you click this point over here, holy cow, that is 100% wrong. Oh, I doubled the wrong number. Diorio, what a goofball. So the height was 40.21. The distance, my bad. So this is why you guys got to check. So for part B, you got to check. We're gonna double the 61. So make this 61, make that 61. So if I double that, I get about 122 feet. So if I go back to my graph, there we go, about 124. So what they're doing is they're taking this value and they're solving this using the quadratic equation to come up with the intercept. But for this problem, if you just want to roughly double the length from the point of impact all the way to the end, you're going to get really, really close. Now notice there's a 3 here. That's because the batter is 3 feet tall. So they should be, so then notice that the y-intercept is here up at 3. That's why it's not exactly 122 feet per se, because you still have that distance there. If we added on that -2 from there, we would get that halfway distance. So for all intents and purposes, all you had to do was really figure out doubling that distance there. So it's about 122 feet. Okay, that's how you do number 30.